Hey guys, the next topic that you're going to tackle with vectors is going to be how to add them analytically. But before we get to that, we need to go back to geometry and talk a little bit about right triangle trigonometry or right triangle trig. So here I have a right triangle and we define the sides to be according to this angle. So if this is our angle that we're concerned with, we would define the side opposite to be the opposite, the side next to it to be the adjacent, and the hypotenuse is always opposite the 90 degrees. And then we use these, the ratio of these creates three trig functions that we'll be dealing with. The first is the sine of theta, and then we have cosine of theta, and tangent of theta. And they're all combinations of these three sides. So sine of theta would be the opposite over the hypotenuse. So we do the opposite over hypotenuse is the ratio called sine. Cosine is using hypotenuse as well, but it's the adjacent, the cosine. So like the co-pilot, it's right next to it. The adjacent over the hypotenuse. And then tangent does not use the hypotenuse, so that gives me the opposite over the adjacent. And y'all may have done this, so toa, to help you remember the order of it. So sine is opposite over hypotenuse, cosine adjacent, hypotenuse, tangent is opposite over adjacent. So regardless, you need to know these trig ratios and how to set them up and solve for them, because we're going to need to find missing sides. So let's see how this all plays out. So here I have a triangle. I'm going to leave this up so that we can see the trig function. So here I have a triangle. Here's my angle. So this is my theta. So opposite the 90 is the hypotenuse. And right next to it is the adjacent. So I want to find the hypotenuse and the adjacent side. I want to know these side lengths. So I have to use the angle and one other side. You have to have two numbers in order to do this. So let's find the hypotenuse first. So therefore, I would be using the opposite and the hypotenuse. And looking at my trig functions, I see that sine is what I'm going to use. So I'll just set this up and fill in my numbers. So the sine of 31 degrees is equal to the opposite over hypotenuse. My opposite is 14, and my hypotenuse, I don't know what it is. We cross multiply, I get h times sine 31 equals 14. It's an h, not an n. And then I can just divide by sine 31. I know that's messy, but so my hypotenuse would be 14 divided by the sine of 31 degrees. And you just put that into your calculator. Make sure that you're in degrees when you do it. Now, if I wanted to know the adjacent side, I would have the opposite and the adjacent. So opposite and adjacent, so I'd be using tangent. So what I would get is the tangent of 31 is equal to the opposite 14 over the adjacent. And it's going to be similar to this. So we'll multiply the a over here and then divide by tangent 31. If you want to take a shortcut, you can just flip these. So a is equal to 14 over tan 31. And this would give me, I'm not going to calculate the value, but it would give me the values. It would give me these two side lengths. We're not going to be finding, well, at some points you may be finding this a missing angle given some side lengths, but we're going to focus on finding these missing values. So here's another setup. So again, I have there's my angle, so this is the opposite. Next to it would be the adjacent, and then opposite the 90 is the hypotenuse. So say I just wanted to find the adjacent. So I have opposite and adjacent, that would be tangent. So I would write tangent of 36 is equal to 16 over a. We cross multiply, so a times tan 36 is equal to 16, and then we divide. So a is equal to 16 divided by the tangent of 36 degrees. Again, make sure your calculator's in degrees. If it's in radian, you're not going to get the correct answer. Now let's take a look at this one. So this one, here's my angle. So opposite is over here. Across from the 90 is the hypotenuse. And that would leave this one. Next to it would be the adjacent. And let's say that I wanted to know this x value. So I want to know the opposite side. I have the hypotenuse, so I need opposite and hypotenuse, which is sine. So sine of 71 is equal to the opposite over 16. Cross multiply, you get 16 times sine 71 equals the opposite. And whatever that value is would be the length of my opposite side. So last example. This time, here's my angle, there's my theta, so I have opposite. Next to it, I have adjacent, and then opposite the 90, I get the hypotenuse. So in this case, let's say I wanted to know the hypotenuse, where x is. So this would be adjacent and hypotenuse. If I go back to the trig functions, my adjacent and hypotenuse is given by my cosine function. So for this one, we'll be using cosine. So the cosine of 18 degrees is equal to the adjacent, 12, over the hypotenuse, h. We cross multiply, I get h, cosine 18 degrees equals 12, and divide, you get the hypotenuse is equal to 12 divided by cosine 18. Again, you just put that in your calculator, it'll give you a value. What if I didn't know the angles? So if I had some right triangle and I wanted to find the theta, and we had, I don't know, 2, 3, and 5. So if I wanted to know this angle here, I could use any of the trig functions. So if this would be my opposite, my adjacent, my hypotenuse. I could use tangent, opposite and adjacent. So I'd do tan of theta is equal to 3 over 2. Now the question is, how do I get theta? Because this is the tangent of theta is equal to that. So on your calculator, what we do is we have an inverse sign. So theta would be the inverse tangent of 3 over 2. So this right here is a trig function on your calculator. So you should see it. You just put the inverse tangent, put your number, and your calculator will tell you the degrees, if you're in degrees. And that's it. Right triangle trig.